Okay, so we are starting from question 4. Find the domain and the range of the following functions. I gave you a task to check if you could find the domains of some functions here. And none of you came back to me with any solution. So I assume that you got 0 out of the questions I gave you. So we go to question 4. Find the domain and the range of the following functions. The first one, function A, f of x is equal to 1 over x squared plus 1. We are finding the domain and the range. First, the domain. It's a set of values of x for which the function is defined. Okay, it's a set of values of x for which the function is defined. So you need to put, if the function is not defined, then those elements, those numbers that can make the function defined, you remove them from the big set, the set of real numbers. Because the numbers we remove will be smaller than the numbers that remain, we always do mention those that have been removed, unless otherwise. So in this case, we are saying, okay, looking at the x that we have in the denominator, the x that appears there in the denominator, it's squared x. So if x is squared, it gives us a guarantee that any value that you take there will be positive. The minimum must be, if we take a 0, then we'll get 1 over 1. But any other number, it will be positive. Now, if it is positive and you are adding to 1, then the denominator becomes bigger than the numerator. That affects the range. But in the domain case, we are saying any value of f of x that we take, that the function is defined. So it's a set of all real numbers. That is the domain. You think of n number, you get a value. Think of n number, you get a value. Meaning that the domain is all real. What about the range? What about the range of f? The range of f is the set of possible outcomes. Which numbers are we able to get after using which values of x? We have said we can use any value of x. Can we still get any value of y? No. We can only get values of y starting from 0, but 0 cannot be obtained, so we'll leave out 0. The maximum can only be 1 included when the denominator is 0. I mean, when x is 0. Okay? This is the function that we talked about here. That's why I'd asked you to answer it, because we talked about it in the previous question. So we'll move to B. B is f of x is equal to 1 over x minus 1. 1 over x minus 1, we want to find the domain. Is there a value of x that when used, the function becomes undefined? Now, a fraction function becomes undefined if the denominator is 0. So we'll say the domain of f is 4x such that x is a real number, such that x minus 1 is not equal to 0. That is the starting point. Okay? This means that we have x, a real number, such that x is not equal to 1. If you take 1, -1, the other side, it will be positive. And that is the domain. So then how do I get the domain? I check if there are values of x that can make the function undefined and remove them from the set of real numbers. So I've removed 1. Everything else is allowed. What will be the range? For you guys, I'm going to teach you the easiest range. Normally, you must find the inverse of these functions. After you get the inverse, then you get its domain. But you were exposed to limits. So to get the range, you just want to have the limit, which is not a difficult thing. You get the limit as x goes to infinity of 1 over x minus 1. Okay? This is where you just check if the powers of the numerator and the powers of the denominator for x are equal or not. If the power of the denominator, of the numerator x is less than the denominator x, then it means the limit is 0. So in this case, we have a constant up there, and then we have x minus 1 down. So it means that the limit here is 0. So if the limit is 0, it means that the range of f is y, a real number, such that y is not equal to 0. Like that. So you always want to check if which numbers can we get. We cannot get a 0 here because the numerator is non-zero. So very soon we'll be sitting in limits when you do calculus. But most of you have done this course before. So when you are looking at the range, you can start using this concept of the limit because it's easier than going for the inverse. See, the f of x given is a function 1 minus x squared. We want to get the range, the domain first. The first thing to write is that the domain is going to be x, a real number, such that 1 minus x squared is greater or equal to 0. That is the domain. Okay? 1 minus x squared is greater or equal to 0. That is the domain. Now, what does this mean? What does 1 minus x squared being greater or equal to 0 mean? We need to factorize this. So we have 1 minus x and 1 plus x. Difference of two squares greater or equal to 0. This means that, well, we could do with x is equal to 1 or x is equal to -1. After that, we now use a testing table or a number line. So let's use a number line. So today I will take with the number line. So this is the number line. I put it this way. And then we have -1 here. We have +1 here. If we pick a number before -1, say -2. If we use -2, you substitute where there is x. What are we having? We have 1 minus -2. We also have 1 minus 2. This will be 3 multiplied by -1, which is -3. So it means that in this interval, we'll have negatives. If we pick a 0 in between here, substitute, we'll have 1 minus 0, 1 plus 0, which is 1, which is positive. If we pick a 2, substitute where there is x, we'll have 1 minus 2, 1 plus 2, which is -1 by 3. That is -3. So we have a negative. So now we have negative, positive, negative. Our interest is to check where it is greater or equal to 0. This is the block for this question. So what we have now is the interval. So our domain is now going to be from -1 included all the way up to 1. Like that. Okay? Do I get any questions? Everything is still okay? We now want to move to the range. We now want to move to the range. So I'll clear this so I can use the space. So the range, so here we have said, so we're dealing with C, and so far I've said the domain is from -1 to 1. So what is the range of f? Look at the value that we're going to use. We'll use f of x, the root of 1 minus x squared. So we are using -1 all the way up to 1. So if we use -1, we'll get f of -1 is the root of 1 minus -1 squared, which is √0, which is 0. F of 1 is the root of 1 minus 1 squared, which is √0, again, which is 0. So it means any negative that we're going to use, negative, positive will get the same value because the x is squared. So then we'll go for the neutral and the 0 one. So 0 will give us the lowest value. That will be √1 minus 0 squared, which is √1, which is 1. So it means we'll have values from 0 and 1. That will be the range from 0 to 1. If you were asked to sketch this function, it will appear like this. -1, +1. When you substitute -1, we get 0. We substitute 1, we get 0. We substitute 0, we get 1. So it will appear like this. So the range, we only have values from 0 all the way up to 1. Okay, let's go to D. What is the domain of f? F of x is the root of x squared minus 1. What is the domain for f? The domain here is, again, x squared minus 1 greater or equal to 0. Let's see the difference. We had 1 minus x squared greater or equal to 0. Now we have x squared minus 1 greater or equal to 0. Do we get the same things? Let's see. So again, we factorize this x minus 1, x plus 1 greater or equal to 0. So we have x is 1 and x is negative 1. So if we go back the number line, we have negative 1, positive 1. So if we pick 0, what are we getting? We substitute 0 here, 0 there, we get a negative value. So it means that the sides will be positive, positive. We want where it is greater or equal to 0, so where it is positive. So it means that the domain of f is going to be from negative infinity up to negative 1 included, union positive 1 to positive infinity included. So that is where we find the positives. The interval 1 to negative 1, negative 1 to 1, we have a negative there, so we don't want to have a negative inside the root. Okay, what about the range? What values are we getting? Look at how big the domain is. So when the domain is so big, it may affect the range. The range is, well, it's possible that if you use negative 1, you can get, if you use 1 or negative 1, you can get a 0 there. So the range is 0 all the way up to positive infinity. Like that. That is how you get the range. When you run, so it will be from 0 all the way up to infinite. Then it means you've gotten the range of the function like that. Any questions? Okay, let's go to E. We go to E, f of x is equal to the root of x squared plus 1. Now the question is asking us to find the domain and the range of this function. For the domain, we want to find the values of x for which the function is defined. Now, if you go inside the function and check what values of x you can use, you discover that you can use any value of x because once you take it there, you will square it. After you square it, you add the 1. So it is positive for any value of x, provided all the values that you're taking there are real values of x. That means that we can use n number inside there. Because the x has been squared, so we can use any number. That's the first thing. The range now. Well, because we could use n number, the question is, are we then able to get a 0 there? We cannot get a 0 because once you square the x, it becomes a plus. It becomes a positive value. So the lowest you can get there is a 0 as your x. And then when you add 1, you get 1. So the minimum value here is going to be 1. All other values are bigger than 1. That is what you will be getting. Because no matter how small the x squared is, when you add it to 1, the square root is no longer 1. It becomes a bit bigger than 1. For example, the square root of 1.01, it is not 1. It is bigger than 1, 1.01. Square root of 1.01, so I'm just going to check. it is 1.004. So it's bigger than 1 for as long as the values you are using are positive values that you're adding to 1 in the range. So that gives us the range and the domain. What about f? F of x is equal to 1 over x. The domain, you check if the denominator can be 0. Is it possible to have the denominator 0 here? Of course, yes. When x is equal to 0, the denominator is going to be 0. The function will be 1 over 0. And 1 over 0 is undefined. So it means that the domain is all x, a real number, such that x is not allowed to only be 0. So x can be anything else, but 0, no, it cannot. Then what will be the range? Again, the range, it will be, for the range we use y now. So it will be all y, real numbers, but this y cannot be 0 also, because the numerator is a constant and the denominator is a variable x. So whenever there's a variable x in the denominator and the numerator doesn't have any variable, it only has a constant, it means that your range is anything apart from 0. So we cannot obtain a 0 after doing the calculation. That is what we see. Any questions? You have to ask if you have questions. And if you don't have, it's okay. If you don't have, it's okay. Any questions? No one has a question. They are too quiet. It's because you didn't do exercise. It's so far. Okay. So G, what about G? G is f of x is equal to x minus 1 over 2. What is the domain here? The domain of f, all real numbers. The range of f, again, all real numbers. Because the denominator is a constant value, so it doesn't change anything. You can use any value of x and you can get any value of y. H, f of x is negative x squared plus 2x plus 7. What's the domain for f? All real, all real numbers. Why is it all real? In a quadratic, you can substitute any value and you get something. Any value you take that gives you some number. Where we have to be careful is the range. Because for the range now, we go in the properties of quadratic function. Okay, so what I'll do is I'm going to say range to weight. When we talk about quadratic functions, which is very simple. On I think on question, this is 5, I think question 6. Find quadratic function. Then we'll come back and talk about its range here. So we go to I. So I is f of x is equal to the square root of x minus 3. What is the domain? The domain of f is x, a real number, such that x minus 3 is greater, x minus 3 is greater or equal to 0 because it's in the root. That means x is greater or equal to 3. What about the range? For as long as we are dealing with the root, 0 to infinity. It's either 0 or, because of this case, where what we are, or the other piece, the x could not become anything less than 0. It means that there we could have an adjustment for the range. Otherwise, for the root, if it's positive outside, then all positive values. If it's negative outside, all negative values are possible. Unless the inside has a restriction, like the case of C. That is where we have that thing. Okay, so this is all about the domains and the range of these type of functions for this course. So far, if we are comfortable here, then we are good to go. Do I get any question? Okay, so no questions.
On G, sir, the question there, it was saying that that one which is saying x minus 1 on the numerator,
Yes.
then on the denominator there's 2. So if you say the range is a set of all real numbers, there if we substitute 1 where there's x, is it not going to give us a 0, then making everything undefined?
No, when 0 is in the numerator, it's very defined. Because then we have 0 over 2 is 0.
Okay.
The danger part is when 0 comes in the numerator.
Thank you, sir.
Okay? So that's how you do things. Okay, so the other thing is, if we move now a bit, we go to question 5. If f of x is equal to 2x squared plus 2 and g of x is equal to x minus 1 and h is equal to x, find f of g and also find g of f, find h of g. So let's see how we get those. So for A, we want to find f of g of x. F of g of x simply means in f, where there is x, take g. That is, in the function f, where there is x, we put g, so we have to square plus 2. So we square g because x is initially squared. This means we'll have 2, where there is g, we put x minus 1 squared plus 2. That is enough. If you want, you can expand to be 2 x squared minus 2x plus 1, then plus 2. So you work it out, it becomes 2x squared minus 4x plus 2, so that is plus 4. You leave it there. The second one is g of h. So again, this means in g, where there is x, you put h. So we have h of x minus 1. But h of x is not. It's 3x. So we have 3x minus 1. And that's all. Then we have part 3, which is h of f of x. This means h of f, in h, where there is x, you put f. That is 2x squared plus 2. Okay, so that would be 6x squared plus 6. Like that. So what does this mean? This means that you guys can do f of g and g of f using the functions given here as an exercise. Whatever we've done on 5a is what we do on 5b. So you inform your friends that please attend classes. Time is not with us because now we are moving. So we move a bit. I've given you an exercise to try. It means that tomorrow also we are going to do more. So today again we'll do only one session because it has to prepare for what is tomorrow. And then from there I'll be free. So we'll have more time tomorrow. So kindly exercise by doing the, even if it looks very simple as it is, try to do it. Try to do it. You have a lot. Unless there are questions. Okay. No questions. So you can end here. If you want to submit the solutions, I always tell you, you can inbox me, submit the solutions. Then for my other viewers, if you want to substitute, if you want to submit and check if what you're doing is correct, or if you have any question from what you've been following, you're free to ask on this one. It's on WhatsApp. So if you're outside the country, you put a +26 here. Then that's going to reach you. Or we can go via the mail. Okay. So we end there.